So in lesson 13.1, we've got some definitions to figure out, first of all. So just a graph, for purposes of what we're dealing with here, is a finite, that means countable, set of points called vertices. Singular for that is a vertex. And line segments or curves called edges. So each line that you see here, these are all called edges. Even this loop is called an edge. And then each of the dots is called a vertex. Now it's important to point out that this right here, where these two lines crisscross, even though it's not, so because it's not labeled, is technically not a vertex. So there's only 4 vertices here, 1, 2, 3, and 4. That one doesn't count since it isn't labeled. We'll always draw them as black dots. That's what I was saying there. They're labeled A, B, C, and D. Some of the edges are A, B, B, C, C, D, D, A, A, C, B, D. So those are all different edges. There is no vertex indicated at that point of intersection, so that's why there's you assume those lines are not connected. A way to think about that, that's what I was talking about with this right here. Way to think about that, it's like 2 wires that are not joined or 2 pipes that are not connected, that just one lays on top of the other, but they're not actually connected. So, just to get in some of those definitions. Oh yeah, one other thing. A loop would be called CC because C is connected to itself with that loop. So that's an edge that begins and ends at the same vertex. We're going to use graphs in a wide variety of situations: floor plans, maps, relationships of countries, friendships, family relationships, all kinds of things. Will be kind of neat applications of some of these graph theory problems. So to practice some definitions, we need to first be able to count vertices and edges and loops. So first of all, how many vertices are there here? Well, that's easy. 1, 2, 3, 4, 5, 6, 7. So we've got 7 vertices. How many loops? Or list them. There's only one. That is... Oh, that's an S. I couldn't tell what letter that was. I'm deleting it just so I can see that mark. So the loop would be called SS because S is connected to itself with that loop. List all edges. Well, actually, SS is one of the edges since a loop is a special edge. But then we've got ST. We've got TU. And I'm going to back up here and just mark these off as I go. Just some good habits. Eraser doesn't seem to work sometimes, so I'm just going to delete them one at a time. But some good habits when you're counting edges would be to sort of mark them as you go. So there's SS. There's that one. There's ST. TU. There's that one. Just working off of vertex U, we have UR, we have UV. Let's see, what else do we have? We've got V connecting to S, so that's VS. We've got VQ. We've got PQ. We've got QR, and I believe that's it. Notice we don't have an RS because R and S aren't connected. We don't have a P connecting to anything else besides Q, so that's all the edges for that graph.